openness is really important because the problem is too big for any one company to solve it alone. Having best of breed solutions and large developer communities is really of paramount importance. So we've really embraced this idea of openness.
In this episode of Embedded Insiders, we're joined by embedded systems veteran Steve Yates, founder of ADI Engineering and now founder and CEO of StellarIoT. Steve dives into his latest venture, a platform designed to support rugged AI-powered digital transformation and remote industries, combining open software, rugged hardware, satellite, private 5G connectivity, and zero-touch AIoT operation. Next, Rich and Vin return with a new DevTalk featuring Hidetoshi Shibata, the CEO of Renesas, for a discussion about his leadership and vision for one of the most influential companies in the embedded space. But first, Editor-in-Chief Ken Briodagh highlights his recent trip to Silicon Labs Works With 2025 with a glimpse of some exciting developments coming soon. Hello, everyone, and welcome to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, and I'm joined, as always, with our Editor-in-Chief, Ken Briodagh, who's back from an important work trip. How
are you, Tiara?
I'm good. How are you?
Great. Glad to be home. Although, as always, I had a marvelous time down in Austin. I was there for a Silicon Labs Works With event, which is always an exciting event for some of the technology that Silicon Labs and their partners are working on. It was a good time, really compact event with lots of information coming in real hot and fast.
Yeah, I've actually never heard of that event before.
Well, it's an internal, it's sort of an internal event to them, to Silicon Labs and their partners specifically. So they don't widely invite the industry to it. But I was very pleased to be invited, and I sometimes find these internal company events really interesting because there's a lot of good stuff that you get there that you can't always get access to at broader events where you don't have time to focus on what one company's sort of partner network is up to.
Yeah, very true.
So yeah, it was really cool. The opening keynotes were really interesting. A lot of insight into where Silicon Labs is going. They had some really exciting stuff. They're partnering with Amazon on Sidewalk, which is very cool. They're working on a really interesting AI tool specifically for software developers to use as an assistant. Basically, it's a Gen AI tool that's really, really interesting and really, really cool. They've got a partnership with Cisco that's going Cisco Wireless rather. That's going to be rolling out very, very soon. So there's lots of cool stuff happening that we were learning about in the keynotes. One of my favorite things that we did is we did a little fireside chat with Bob Metcalfe, the inventor of the Ethernet, of Ethernet, and creator of Metcalfe's Law, which he's sort of a luminary in the computing space. These days, he's working with geothermal energy company and working on energy, which is kind of interesting and cool. But we also got a chance to sit down with Matt Johnson, CEO of Silicon Labs, and Bob Conrad, who's the SVP of Worldwide Operations, and he came to that off of the board of directors and joined the company proper from the board. And Manish Katari, who's their SVP of Software Development, talking about some of these new products and initiatives that are coming out. Their Series 3 chips are going to be dropping this year, I think, maybe early next year. They said, but you'll have to read the article that I'm working on to find out all the details on this stuff. But it was a lot to cover, a lot to do, and it was great to reconnect with some of these folks and sort of see what everybody's been up to.
Yeah, sounds like we have some interesting things to expect from Silicon Labs in 2026.
Absolutely. And yeah, I was really excited to get some insight and an insider's look at what they are working on. So yeah, keep an eye. Article is going to be coming out, and I'm probably going to be talking about it in this week's In Case You Missed It too.
Sounds good. We'll let the audience stay tuned and keep listening for our upcoming interviews in this podcast.
Awesome.
Now, here's founder and CEO of StellarIoT, Steve Yates. So, Steve, I know we're talking about, your experience in the embedded systems industry. Can you yourself give us some background about yourself and just what you're up to?
Sure. And thanks, Tara, for having me on the podcast.
Yeah.
So I am a 35-year industry veteran in the embedded systems space. I started a company back in the 90s called ADI Engineering, and we developed a really close partnership with Intel Corporation. Back in the day, we developed reference designs for their communications and network processing SoCs. We were able over time to leverage that relationship into a scalable, high volume, white box type of products company for edge networking devices. We served a number of customers, large tier one OEMs. We worked extensively with the ODM community. That company was acquired, and I've now on to my next thing, which is StellarIoT.
So, for those who don't know, what is Stellar IoT and how did this, idea evolve from concept to reality? And a bit of a loaded question. What else? What was missing in the market that made you believe or just made you get started?
Yeah, sure. It's really a combination of things, and Stellar IoT ultimately, the idea is that it's an open, rugged, and zero-touch AIoT infrastructure platform that's really built from the ground up for critical remote industries. These are industries that exist in rural areas and ultimately provide really important services. They feed, power, transport, supply, or protect all of us. And the idea was really born from several things. First of all, in my 35 years, I've really observed that the most underserved locations really are the most in need of digital transformation coming from technologies like IoT and now AIoT. But they exist in austere environments that lack really the critical ingredients that are commonplace in more urban settings or at the near edge. And some of these are pretty basic, fundamental things like reliable power or connectivity. But there's other big gaps as well in terms of trained IT support personnel. And these are really required to deploy conventional solutions that are being developed today. Also, I've been a Starlink early adopter for over 3 years. I personally have residential and a mobile Starlink installation on my Sprinter van. And I've seen over that time how ubiquitous satellite connectivity is a game changer for remote access. But ultimately, it just exposes what I'm calling a new digital divide that's not about raw connectivity, but really it's about the capability to deploy, secure, and operate AIoT solutions where, like I said, the power's unreliable, the environment's harsh, the infrastructure in general is just really fragile. And the nearest data center or support team is hundreds of miles away. And I've seen that enterprise IoT is just too cloud dependent. Coverage is too inconsistent, and conventional AI requires too much manual setup and ops to be practical in these types of environments. So the idea is to build a new type of infrastructure system. It's a hardware and software platform that integrates low Earth orbit satellite as the primary backhaul with other satellite geosynchronous or cellular or fiber or even other terrestrial broadband as a backup where they're available and economically feasible. Also, it integrates high performance multimodal local wireless, which is really important for users of these industry or users in these industries rather. So a combination of Wi-Fi, long range wireless interfaces such as LoRaWAN, and increasingly Wi-Fi Halo, which is really interesting, by the way. Also, it really has to include, and our system does include, on device edge AI inferencing. And it's important to eliminate cloud round trips and increase autonomy in these environments. And, we've really embraced openness as a critical design principle. And all of it, the hardware aspect has to run off solar or battery backup. It has to support secure over-the-air updates, and it needs to be deployed without specialized field technicians. So really, I guess bottom line, we're trying to remove the friction from edge AI deployments in places where connectivity, time, and resources are scarce. And that's what StellarIoT is.
That sounds great. So when you're deploying such a packed system in an environment that's not used to it, how did you go about it? Like, what were some of the challenges that you knew you needed to address, at the beginning and throughout the process?
Yeah, great question. So, you're really designing, I guess, for kind of the inverse of the cloud or maybe the intermittent presence of the cloud. So as I said, these are austere environments where basic things that you normally take for granted are constrained: power, connectivity, environmentals, and the fact that there's nobody on site to fix things or recover the system or reboot it if it needs that. So, this gives rise to I think, a pretty interesting and unique set of engineering challenges. First of all, power efficiency. You're not running in a gigawatt class data center powered by a nuclear reactor. You're running off solar or battery or vehicle power, and every watt counts. The systems have to be resilient. They have to survive and actually even thrive in extremes of vibration or weather or dust. They have to be autonomous, which is a big challenge and really changes your design focus, right? No one's coming to reboot the system, like I said. And so you have to provide secure remote recovery, self-healing, self-optimization, and zero touch provisioning. And lights out management becomes a critical need that is somewhat unusual in edge devices, especially far edge devices. And then kind of another big engineering challenge that I think the world is starting to recognize but really hasn't come to terms with yet is that AIoT devices really challenge existing access networks at their weakest point. AIoT devices are pushing large volumes of time series sensor data or image or video stream data upstream over the uplink. And today's access networks are built for a downlink heavy world. They're built to deliver content to humans consuming this content. They're not built to provide uplink heavy connectivity for AIoT devices. And, that sounds a little out there or maybe a little arcane, but really it's a big issue because the networks just aren't built for this. It's hard to have billions of AIoT devices all streaming 4K video streams up to a cloud data center for inference. It just doesn't scale. And so that, along with end user concerns about data privacy or security or data geolocation, and also who monetizes their data, all of that points to the need for local on-device storage and AI inference. And so I think operationally, the biggest challenge is deploying at scale without all of these things that you take for granted in the city center. And that's where autonomy, modularity, and robust lights out management and recovery all become really critical.
So engineering wise, and I hope this question isn't too repetitive, but you
Yeah.
have so many different features, important features on this platform, the open hardware, open software, private 5G, zero touch AI. How do you, manage a platform that integrates all of these features?
Yeah. And that's, I think, the really critical pain point here. And I think um, the best way is really to have openness as a core design principle, and to have a view primarily on use cases and end user experience, not the latest standards body outputs or hype that's coming out of the industry. So openness is really important because the problem is too big for any one company to solve it alone. Having best of breed solutions and large developer communities is really of paramount importance. So we've really embraced this idea of openness. And like I said, I've been working not only in the embedded systems world, but open software and open hardware for decades. So what we're doing is building on top of best of breed solutions, including OpenWRT, OpenBMC, Open Wi-Fi, Open LAN switching, Ubuntu Linux, and other projects and distributions. And that gives us really open and extensible routing and device management and recovery and OTA updates and security and more, right? I mean, that's not an exhaustive list, but all of this is secured, it's remotely managed, and it just works. And like I said, it also gives an interoperable architecture that allows us to benefit from a large developer community. Open hardware is really important too. As I mentioned, we are developing a hardware platform. Frankly, it's not our main focus. Our main focus is on the software and services to make this all work. We openly welcome and are working with ODM partners to build compatible devices. The more, the merrier. We really want to encourage an open hardware ecosystem here. But we are developing our own primarily because we see the need for a reference architecture that shows the way to develop and deploy these types of devices at the far edge.
So I'm wondering, is your platform deployed anywhere? Like, where are you now? And I don't know if you can speak to any of your customers, but just kind of where are you now and how is this going, I guess?
So where we are now is we are finishing up the hardware development. The software development is well underway, and we're heading into initial pilot deployments in Q4 with first general availability planned for late Q1 of 2026. As I mentioned, it's a pretty significant technical challenge, but we feel like we have the right team of experts and developers defining and architecting and actually implementing this. We're talking with customers on a routine basis. We have a number of pilot sites, high impact pilot sites lined up, and we're excited and eager to get into volume production.
So, with all your experience in the industry, do you have any advice for engineers who are just getting started trying to navigate the AIoT landscape, especially for those who are working in the data center? Do you have any advice that you would give them for getting started and designing at the edge?
Yeah, great question. So, I mean, at the edge, the constraints are really dramatically different than those inside the data center. AI at the edge, really, it's a systems problem. It used to be a connectivity problem, but like I said, ubiquitous satellite connectivity has really changed that. In fact, I'm doing the podcast over my Starlink right now from the middle of nowhere. Um, so it's a systems problem, and we need smart infrastructure that's capable of running offline and capable of self-healing and thrives, whether it's running at a farm or a freight terminal or a mine or a disaster site without nearby support teams. So this is a very different environment than the data center. You have to design really for the situation where there's zero connectivity with graceful degradation, even though you might have a connection. And like I said, with Starlink or Project Kuiper and other satellite constellations, that is widely available now, but it's still somewhat fragile. You may not have redundancy, and it may not be available when you need it most. So, one piece of advice is design as if the cloud doesn't exist, or maybe better put, design for cloud optional scenarios. Um, you have to think about power as a really critical resource too. And at the remote edge, you're going to have much less of it. And I think fully embracing open and interoperable software projects and protocols is important. As I said in a previous answer, full stack AI development is a huge problem, and you're not going to be successful all on your own without best of breed solutions and open developer communities. Local decision making and kind of breaking from the cloud centric AI approach that the industry seems to be making is a critical design consideration for the far edge. The systems have to be autonomous and fail safe. They can't be reliant on centralized AI inference or orchestration or operations. And every time that the system needs to take a round trip to the cloud, you're just introducing risk and delay and potential unavailability of that link, and ultimately cost, because these links aren't exactly free, and a lot of them have data caps. And I guess most importantly, really, it's kind of almost seems like a basic piece of business advice, but that's because it's so true, which is to get out and talk to real customers, understand their pain points, go visit farms or mines or emergency response agencies, and talk to domain experts and understand what they really need, not just what the latest standards body or analyst report is thinking they need. Oftentimes the remote edge is overlooked and not really well understood, and so you need that firsthand knowledge. And the edge is just, it's really messy, and that all has to shape your approach. And I guess the last piece of advice, I would say that you have to think, at least in part, like an operator, not just like an engineer. Consider what happens when your deployment is 100 miles away from the nearest human, or at least the nearest trained IT expert. And that mind shift really, I think, makes all the difference.
Amazing. That sounds like great advice. So looking towards the future or looking into your crystal ball, as we like to say over here, where do you foresee this intersection of edge AI and non-terrestrial networking and autonomous operations heading in the next I won't put a time on it, but in the next
Yeah,
couple of years?
sure. I mean, I think in summary, I think we're headed towards a new type of autonomous infrastructure that's built for places and use cases that conventional networks and conventional cloud service providers today can't serve well. And I think that's leading to, I don't want to go out on too much of a limb here, but maybe I will. I think I can see a rare and really interesting sort of technology inversion that at least could form. And that is where rural areas don't just follow or accept, table scraps in the AIoT race, but really, I think they have the opportunity to actually lead by blazing a trail that places use cases and customers and end user experience at the center instead of telcos and cloud service providers and conventional approaches. And if they can build such a system that's open and inclusive and flexible and agile and resilient just out of sheer necessity, that system is useful in a huge array of use cases, not just in rural areas, but everywhere. But I'd also expect to see AI models that are fine-tuned locally, that run on device, that incorporate federated learning based on real-world data from the field. I'd expect to see edge nodes that cooperate and build resilient mesh networks. I'd expect to see a shift away from cloud-first mindsets to cloud-optional architectures. And I would certainly hope to see entire industries adopting AIoT as their default infrastructure. And these are, again, places that exist in remote areas outside of the urban center. So agriculture, energy, logistics, construction, emergency response, mining, and so forth. So I think what is really happening, which I think is interesting, is that edge AI out of necessity isn't waiting for 6G or 3GPP committees or regulations or telcos or cloud service providers to catch up. It's not really about replacing them, but it's about extending intelligence and resilience to the furthest edges of the real world. And it's happening now, and it's being built by those closest to the problem. And we're really excited to be part of that. I guess I would just close by encouraging people maybe to check out our website, StellarIoT.ai, to get the latest and greatest that's going on, to stay tuned. And, I'd just like to thank you, Tiara, for having me on the podcast.
Now, here's Rich, Vin, and Hidetoshi Shibata, CEO of Renesas.
Good afternoon, and welcome to another episode of DevTalk with Rich and Vin. I am Rich. I'm Rich Nass with Open Systems Media. The guy on the other end there is Vin D'Agostino. How you doing, Vin?
Good, Rich. How are you?
I'm really good.
Good.
Things are going very well. But it's been a while since we have done one of these podcasts.
It has been a while.
I'm going to blame you because I'm here all the time. Where have you been?
I've been traveling a lot for work with customers, and my grandson was just born, so lots of stuff going on. Yeah.
Congratulations. That's awesome.
Thank you.
Wow. Very good. Very good.
Yes.
So where do your travels take you to?
I have been, in the last 2 months, I've been to California twice, to New York once, to Columbia, Maryland, to do some work with a client there. And where else did I go? Monterey for an executive development conference. And I'm headed actually to Manager Tools M conference in LA next week. So lots of stuff going on.
Very good. Very good. I have also traveled. I went to Costa Rica. I went to St. John, and I went to Panama City Beach.
Why do I think that's all vacation and not work, Rich?
One of us has to have fun.
That's true. That's true. So
Very good. Speaking of which, what's the picture behind you there?
oh, that's Hedy Lamarr. She was an actress in the late 30s and early 40s, and most people know her for that.
The
But
late 30s and the early 40s. So you must have been a big fan of hers at the time.
well, I'm a big fan of hers. Not at the time; I wasn't even around. I am a big fan of hers, but not for her acting. In fact, everyone said she wasn't a very good actress. She had a PhD in mathematics, and she actually became an actress because she said math didn't pay very well. And the reason she's on my wall is that she holds the patent for frequency hopping. She developed the math for this on her own. She went to a friend of hers who was a player piano manufacturer, and he built a mechanical simulation of how it would work. And she actually went to the U.S. Department of Defense to say you could use this to not have enemies jam your signals. And the head of the Department of Defense said, Miss Lamarr, you're much more valuable to our servicemen as a pinup girl. And they didn't take the technology. So she got the patent. And now everything that we have wireless, Wi-Fi, cell phones, Bluetooth is all based on this technology. And it really means that you don't know where the inspiration or the basis for a lot of the stuff that moves the needle in your industry really comes from.
It so comes is that the story you tell your wife when she says, why do you have a pinup girl on the wall in your office?
That is, yes. And I've actually had it in my office, in a couple of corporate offices, and people are like, why do you have an actress on your wall? And I tell that story. And so, when you think about even our industry, the people that have contributed to this industry, some people know, companies like Intel is on everybody's desk. They know that. But you look at a company like Renesas, Hitachi, Mitsubishi, NEC. Hitachi had the first programmable part that was in a plastic package, completely reducing the price of it for the market, making it available to other people. They had the first part with enough RAM on it to write code in a language like C instead of assembly to allow things to move more quickly in development and reuse code more easily. They worked with Microsoft to develop Windows CE. Nobody knows that. Windows CE originally only ran on SH parts. NEC and Hitachi had the first fuzzy logic compilers back in the late 90s, before we even knew what fuzzy logic was. So there's a lot of stuff that we use today and look back on and we've built stuff on that we don't even know who contributed it to make that happen. And we're really lucky today, actually. Because,
why is that?
Because our guest today is Hidetoshi Shibata, who's the CEO of Renesas. And
no way. Really?
Yes. I have known Shibata-san for over 10 years now. I didn't send you an anniversary card, I'm sorry. But I joined Renesas in 2015 and met him on my first trip to Japan in his office in the old building before they moved out of downtown Tokyo. That's how long I've known him.
You got Toshi to come on our podcast. He doesn't come on he doesn't do podcasts.
I know. We're actually honored and should be honored because this is his first podcast ever. So without further ado, I'd like to introduce everyone to Hidetoshi Shibata.
Hi, I'm so honored to be on your podcast for the first time in my life. Please call me Toshi instead of Hidetoshi, which should make it a lot easier to address me. Although I have no association whatsoever to Toshiba, I prefer to be addressed as Toshi.
Fair enough.
Yeah, but I do have an association with Renesas, which is the creature born by the merger among Hitachi, NEC, and Mitsubishi, the companies you talked about, them. Mm-hmm. I came to Renesas back in 2013 as CFO. 3 years into the formation of the company, as you know today. Since then, wow, it's been more than a dozen years, and I became CEO back in 2019. This is something I often use as one of my fun facts, which is about, the license to drive Shinkansen bullet trains. I earned the license way back when late 90s when I worked for a railway company out of Japan. And actually, that's where and when I was truly exposed to the power of semiconductors and digital technologies, which I can, talk a lot more if needed afterwards. But that's, what fascinated me to electronics. And since then, I kept following the electronics and, look where we are, look where I am now. So
Yeah, I
that's the
mean,
history.
even in your era, Renesas, until Renesas released the Synergy product, no semiconductor company released code that they said would be acceptable for production. And Renesas again led the industry by doing that, and everyone else started doing the same thing. And that has morphed into the RA product line and the FSP, which a lot of people are using. So it's really exciting to see what you're doing. And with the three companies, they really have been a sort of a high touch customer company, working with very large companies. And so a lot of our mass market listeners may not even know who Renesas is. They may have heard of NEC or Hitachi for other reasons. So we're really excited to have you on the program. You could tell us some of the things, anything that you can share, publicly, things that are in store for our future in the industry, or your other insights. I mean, you, as you said, you came from the train industry and you have a license to drive a bullet train. I didn't know that about you. That's exciting. So, like an outsider coming in, you have a different view of the business, I think. So
Well, hold on. How did you get from driving trains to working at Renesas? There's a disconnect there.
Well, the story is not that, fascinating or exciting. Like I said, I was exposed to the power of semiconductors while I was driving bullet trains, because there were three types of trains that I was trained upon. The oldest one was basically fully analog based, and there the experiences of 50 years old master driver mattered a lot. But the latest version, I mean, basically those experiences are totally gone, because all you could do was to watch what's happening on the monitor and take corrective actions, I mean, digitally. So between the oldest version and the newest version back then, I mean, there's a ton of difference between what experiences or learning curve mattered. And that kind of pushed me into, although I switched my career from a railroad company to a private equity industry, which is also a different industry from semiconductor, I kept following what technology can do in terms of driving innovation in a way that touches our human lives. And my last investment that I took lead upon in the previous capacity as a private equity investor was basically about investment into Renesas. And, that again drove me into switch my hats from an investor shareholder hat to an operating hat as CFO. And since then, things happened. So where I am.
But we also want to throw in there, you also took the time to get an MBA from Harvard, and that's
Yes.
not something that people driving trains typically do.
Well, Harvard is about general management, leading people, and in that respect, my experience at railroad company hopefully stood out as something different and something of relevance to other students. So
Very
that's
good.
great. Yeah. So what do we have in store coming from Renesas to help the industry move the needle again?
Well, rather than talking about the immediate future that's right ahead of us, I really wanted to talk about the long-term vision here,
Okay.
which is about basically bringing the electronics design, production, and lifecycle management capabilities to really a much broader audience. Because one thing that surprised me a lot while at Renesas is electronics has been and still is being in the hands of very few number of experts, and only at the COVID-driven supply crunch, all those managers and politicians and whatnot were made aware of what electronics is all about, beginning with semiconductors. But in the future, I think if we sort of liberate, if you will, the electronics and handling thereof to a much broader participants, I thought we can really accelerate all those innovations in a way that will help our human lives in an even more impactful fashion. That's where this digitalization vision came from.
Okay.
And should I continue?
Yeah, please tell us more.
And this digitalization is basically connecting all the dots from ideation to the discovery of the components and parts available, and then designing electronics, which is mostly centered around the board, PCBs, and then the manufacturing of the boards and the system, and the life cycle management of the components. I mean, tracing the changes, tracing the origins, and whatnot, in a seamless fashion. And currently, each and every part is being automated or helped by different, CAD system, CAE system, and whatnot, but not in a sense that connects all those components seamlessly. And that's what I'm aspiring to do after acquiring Altium.
I had a feeling that's where you were going with this, because you've brought some non-traditional semiconductor stuff into this conversation about doing board layout and actually manufacturing the boards and product procurement and all that stuff. So what was the process that made this acquisition happen? Was it where you said, I think we need this technology, or was it, hey, Altium does some cool stuff? Which way did it come from?
Well, very good question. Honestly, I've been mulling over this idea for some time. In fact, I flew this idea by some people, and everyone that I talked to loved the idea instantly, with a lot of doubt in their eyes. No one really believed, a crazy idea like this will be materialized at least in our lifetime. So I kept thinking about it, where to begin, how to start, and then I came across a company called Altium, and I followed them their progress with a lot of fascination, and I decided maybe this is a company I should run by my idea. And then I flew to San Diego a few years back, met with then CEO of Altium, who's still with us, Aaron Mirkazami, and then kind of fearfully initiate a conversation with him, and he was also thinking exactly along that line. So we basically hit it off professionally on this matter. And then the journey really took off from there. So that's the genesis of this idea.
So what does success look like? How will you know when this acquisition is what you thought it was going to be?
Of course, I need to hold myself accountable for the horrifying shareholders. So, so I set the milestones and the KPIs and whatnot. But really, with respect to the vision we said I have, think about the way you use PCs now. You don't really think about, drivers, or you don't really think about, the versions of different software. You don't really think about, SCSI board and whatever. I mean, you just ramp up, boot up your PC,
Mm-hmm.
and then almost automatically connect to the internet, and that's it, right? That's how you use PCs. But I know you are mature enough to know, what PCs looked like back in early 90s, or even, late 90s. Things were a lot different. And you needed a lot of help from the expertise or knowledgeable people
Mm-hmm.
to make your PCs really functional. And that's the way I naively, describe the current state of the electronics. So the success should look like the way you use PCs. You can do the electronics. I mean, without really requiring all those sophisticated expertise. That's the state of the success.
So you're looking at this, if I'm understanding this, from the system design perspective. What do I need to make a system, and all the pieces that go in, the components, the board layout, the firmware, the drivers, the middleware to make motor spin or internet connections or whatever, all in one enclosed workspace, if you will, sort of a grandiose version of what we would call an IDE today, where we're writing code, building code, and debugging code. But now this brings that thought process to the system level.
Yes and no. So that's
Okay.
a tricky part.
Okay.
Because in essence, that's what we are trying to do. But not in a way that, we incorporate all those ingredients in a way that we do with IDEs. Because I do know, people love the tools they use, right? And that won't change overnight, or maybe infinitely. So the way we are thinking about it is we will provide a digital platform where we provide the basic elements, such as, digital thread that will connect through all those different elements that's required to enable electronics design and manufacturing from end to end. And then on top of that, we will work extremely hard to ensure seamless connectivity to different tools, such as discovery tools, design tools, simulation tools, and the lifecycle management tools, in a way that users have the freedom to choose whatever tools they like, which is seamlessly connected to this digital platform. But the reason, why we are doing it is perhaps if you use the tools we provide, and hopefully the devices will provide on this digital platform, you can use them probably a little more easily, a little faster, a little less cumbersome fashion. That's the idea. But we will ensure the openness of this platform. So you have the freedom to, choose whatever tools and ingredients from.
It's great. Is there a name for this platform?
The basic technical platform will simply be provided by Altium, and the Altium is now making a pivot from a product company to a platform company. And then on top of that, we will be building our own platform called Renesas 365,
Okay.
where you get to enjoy the benefit that I alluded to.
And what's the
So
time frame to have this all?
I was just going to ask about
all this built
timeline
out?
myself, Rich.
I mean, that's the toughest part.
Yeah.
So if you look at the trajectory of Microsoft Windows, it took a whole decade or even longer for them to come to where they were able to kind of wow the world with the introduction of Windows 95. And there's a company called Siemens out of Germany who's doing something similar to what I talked about at the kind of higher level, at the factory level, production system level, but not at the electronics level. And it's been 18 years since they embarked upon this digitalization journey at their level. And, they came to where, it is as good as it can be. So probably it will take a very long time for us to be able to make it really like the way I talked about. But the point is, maybe over the initial 5 years, we will make it something like Windows 3.1 as opposed to 95. So at least more people enjoy using it, more people get excited as to what comes next. So that's the time horizon we have or I have in mind.
Okay. That's great. That's great.
Are we
Rich?
able to shift gears into something totally different?
Yes. Go ahead, Rich.
Okay. Where do you think Toshi AI fits in within your organization? Is this a tool that you want your engineers using and taking advantage of?
Absolutely. As you know, the AI probably is at the infancy still, and it's going to take some time for AI to have really meaningful impact on the way we do business. But the emergence of the AI as we speak today is one of the key triggers for embarking upon this digitalization journey. Because without the AI, as we talk, today, any of these functionalities or capabilities that I talked about could just be a pipe dream, because it takes so much time to do any of those perform those functionalities digitally on cloud. But with the emergence of AI, things will be dramatically different. So now we are trying to make our work a lot more efficient by taking advantage of the AI that is already available, such as coding assistant, such as robotics process automation and whatnot. But really, the value that we should be able to extract is to really make this digital platform called Renesas 365 really relevant and effective in a way that can, give you a lot more proposals, or that can provide you with, more context that can assist you with a lot more information that is needed without, referring to, 3,000 page thick, user manual. So those are the ideas that we have in really exploiting the power of AI.
So a question I ask often, if you're an entry-level engineer, should you be concerned that AI will take your job?
Well, I understand the sentiment, but I don't really believe it that way, because I do believe many of the engineers have fun making some product, right, that work, as opposed to spending a countless number of hours going through the user manual, or looking at watching countless number of YouTube tutorials to know how to hook up the board. I mean, those are really low value added element, and that's where AI should be able to extend a lot of help, so that all the engineers can focus on what's differentiating, what's more value adding, as opposed to and just ensuring all the rudimentary elements in place. So I'm a firm believer that AI should be able to liberate all those engineers who might be listening to this podcast from those rudimentary, low value added work, so that they can really absolutely focus on what's a lot more fun and exciting.
Yeah,
That's a great answer. Thank you very much.
Yeah, I mean, we've said over and over, even on this podcast, that for most people, they won't be replaced by AI, but they could be replaced by somebody who knows how to use AI as a tool, right?
That's
and
correct.
that really speaks to that. If you get more efficient at doing the rudimentary things, it gives you more space for innovation, and that's what engineers do really well. And AI doesn't really do innovation that well yet.
Yeah,
Maybe one
exactly.
day, but
Exactly. I mean, imagine the days before the introduction of spreadsheet.
yeah.
I mean, how did we do all those calculations? That was really cumbersome, painful. And basically, in my view, a little more sophisticated version of spreadsheet, that's what AI will do to
Yeah.
really, liberate people.
Yeah. My mother was a bookkeeper, and and she worked in an old office. And I went in one day, and they had these buckets of manila cards where they wrote all the transactions on them. And I'm like, why aren't you using a computer? And she's like, this works just fine for us. But of course, long term, it wasn't going to. So, there's a management philosophy that says you should always be pushing work down to the lowest cost producer. So if there's something you can do, but your direct employee can do it just as well or almost as well, you delegate it down because it's being done at a lower cost, and it frees you up to do some of the more higher value things, right? This is a fundamental management rule, and technology does the same thing, really. It allows you to eliminate the manila cards and do it in a spreadsheet or do it through a computer and all of that stuff. And AI will do that as well. So
absolutely.
Yeah. Toshi, thank you so much for joining us on this call. We really appreciate you taking the time. I know you have a very busy day and a very busy job, but we really appreciate hearing directly from you on this stuff. And I hope that we can revisit this with you every so often and see how you're doing on your Renesas 365 journey.
Thanks a lot, Ben, and thanks, Rich, for having me.
We want you to come back. We want this to be a regular thing.
Yeah, we want you to come back. This has been really a lovely conversation. Thank you so much.
I'd be honored to. Thank you.
That was really cool, Vin. So
yeah,
I have to say, I'm impressed that the guest you were able to bring in. Good job.
Well, thanks. I've known Toshi a long time, so.
Okay. He really came across well. Although his story about being a train driver, I had to throw in the fact that he's actually a Harvard MBA, because I don't want people to get the idea that he went from driving a train to leading this mega company.
No, I didn't know that about him either. I knew he had worked in the train industry before moving into investments, and most people know that he joined Renesas after the earthquake and tsunami, and they had problems at factories and things, and so he joined as part of the InkJ investment, and then really thrived in that environment, and ultimately became CEO, which is exciting for him, and I think exciting for the company. And it's really nice to get insight at that level in a company that size, right? We've done that a couple of times, and it's always been interesting for us and for our audience. So.
And I ask this same question all the time, and it's always interesting. And I don't know if we've gotten the same answer twice about the entry-level engineer having to be concerned about AI taking his job.
Yeah.
He had a totally different answer. And we've had everything from, hell yeah, I'm really concerned, to no, not at all. And he was sort of in the middle.
Yeah, well, I mean, he comes to the industry that he's in, both industries, from a different perspective, right? Investment bankers very often have grown up in the banking industry, and he didn't. And people running semiconductors often were either sales or marketing or engineering people, and he wasn't. So his perspective is different than other people's. And I think that was an interesting thing some of the stuff he said I knew, but some of the stuff he said I didn't know. So that was pretty cool.
Absolutely. Always good to talk to you, Vincent.
Great to talk to you too. And you keep going on your vacations and I'll keep going on my work trips.
Works for me.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.